So let's look at some of the commands that we can use in terms of managing our blockchain. So what we'll do is we'll just get started with the with our management interface. We can see here that the blockchain is running. There's no mining just now, as you can see. We're up to this block just now, and the miners aren't actually started. Okay, so that's started. So the one thing you should notice is the modules that have been integrated in here. So we can see admin, ETH, miner, and Web3. So those are the main ones that we'll actually use. So if we want, we can actually have a look at the syntax of them, and it'll show us the basic properties and also for any functions that we have. Okay, so here are the functions here, and here are some of the properties. So data dirt is one that we could use, and that shows us where the blockchain is located. Just now it's on the D drive in the ETH folder. Okay, so another one that we have is our miner API. So we can, if we want, we can start our miners. We can see there's a start and a stop function, and then we'll have a look to see what the hash rate is. Just now probably won't be very high. So we've got 13,587 hashes. And we can see here that we're starting to mine and add new blocks. So I just stop that. We can set the gas price and so on, but what I'll do is I'll just stop it to reduce the CPU utilization. Okay, so that's miner. And then we've got this personal one, which allows us to be able to look at the accounts on the system. So in this case, we can use the list accounts. That returns back a list for us, which should give us all the accounts. So you shouldn't really delete accounts on a blockchain. It can cause lots of problems. It's not a good idea to lose the private key too. So what we'll do is we'll add, so we can add our personal account here. And let's just add accounts, new account. I'll give it a password capital P, and that's added to that, and we'll go back to our list accounts and we'll see that's been added from there. So what we often have to do is to unlock an account. So we'll just unlock this account here. We get back a true. Okay, so all of these commands we're using could be run within JavaScript. So the next thing we'll have a look at is the Web3 API. So with this one, there's a rich source of functions and that we can use to be able to understand the blockchain. You can actually see here that it even has the accounts listed and where the keys are stored. So you can see the account that we've just created, the key is here. That's where the public and the private key are actually stored, and these are locked just now. Okay, so we'll have a look at a few simple ones just now. The Web3 version gives us some idea of what version of Ethereum we're using just now. So we can like that. We could also do we can also set that as a variable. Okay, so that should now be in there, and then we can just list that one like that. Okay, so we can look at the node that we're using, and then also the version we're using to and the hashing function that we use is pronounce kitchak 256. So what we'll do is we'll just see if we can hash hello just to check. So there is the hash, 256-bit hash for hello, and we'll try here just to see if we get the same value here. So it's not SHA-3, it's kitchak, and hopefully for the 256 we see a hash there. Starts with 1C and ends with C8, which is correct. Okay, so that's the hashing method that we use. All of our transactions in a blockchain, our blocks have a hash, and that's the method that they use. Okay, so we can also do some basic functions like a 2hex. Okay, we can take an ASCII and we can convert it to hex value. So when we're storing data on the blockchain, we store it as a hex value. So even things like a file or a string is converted into hex value and then stored in there. And then we can do the reverse. If we read something off the disk and that's the hex pattern, we can convert it back into a string with that one. We can use the 2-decimal if we need to, and do the reverse from there. We have a function for that, and then we can look at our currency. So this is the currency in ways that we have for the this core account, which is the ID that we're logged in just now. And we can also look at it in terms of our ethers from there. And Web3 also comes with a big number generator and method that we can modify big numbers. So that's the big too big number there. Okay, so it's possible for us to also to run this as a JavaScript file. So this might be in the web page, so we can run it as a web page, or we could run it as a JavaScript file here. So there's just loading up our values into a variable, and then we're just going to print them out. So I haven't checked the syntax of this, but here goes. So we'll just load the script. Okay, so we have a problem on line 18. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, let's try that one. That's fine. Okay, so you can see it just runs through all the commands that we put in before, but we can run it as a JavaScript. We can also, as I said, run it into a web page. Okay, so we can also use Web3 to be able to show our accounts that we have on the system, and then to set the default account that we're going to be using in terms of our accesses. Okay, so that's the default account there. We can also look at the name of the default block. The name of the default block it's just latest. And then we can look at the Coinbase, which should be the account that we're currently logged in with. And it's that one there. We can look at the gas price that we have for our Ethereum. The current gas price is this. Okay, so as we've seen before, we can start the miner, and then we can look at the hash rate within Web3. We can also look at the current block number. Okay, if we look over here, here we are, and we'll have a look at the block number there, and we can see we're on 1596. Okay, so that's the last block. So it looks like the miners were stopped before they got to that block there, but that's the current one there. And we can use this to be able to look at the balance within any account. So we can see here, that's the amount of cryptocurrency that we have. And we can also look at any transaction that we have. So if we have a transaction number, there we are. So this is a block hash. That's the hash of the block that it's associated with. It's in block 45, and it was a transfer of credits from this account to this account. Okay, and this was the number of credits that were sent over. We can look at a certain block if we need to. So actually, let's look at there's block 1000. We'll have a look at block 45. It's got one transaction in it. If we look at the other one, it has no transactions in it. Okay, so it doesn't have to be that there are transactions inside any block, but there can obviously be many in there. Okay, so the block itself has it shows the miner which managed to find the hash. We'll also see things like the timestamp, the transactions in it, and so on. Okay, so once we have the ID of a block, we can actually look at the whole block itself. Okay, so we can look at the block number, or we can look at the block hash. So in this case, we're taking the hash value here, and we're finding the block on the chain. So obviously, if I used the wrong hash, then it won't be able to find that block. Every block that was ever created should have a unique hash. No two hashes really should ever appear. So if we know the hash of a transaction, we can actually view it. Okay, so that was a transaction we looked at before. And then what we can do is we can, in JavaScript, we can easily just assign this object to a variable, and then we just use t.gas, tx.gas, tx.value, and we can actually display all of our parameters. So I just paste that in. This is there, and I can say console.log tx dot let's look at the gas price. And there's that. Okay, so isn't that wonderful? So that's the way that you can access your blockchain using JavaScript. So obviously we can create that within a web page quite easily, and we can link to our blockchain, a blockchain service, and then just as we've done, we can use all that JavaScript that we showed there to be able to create transactions. Maybe someone might want to buy something. We can interact with a blockchain from here. Okay, so that's been a basic demonstration of how we manage our blockchain.